Hey guys, welcome back to another video. My name is Melina and today we're going to be doing a little bit of review on carbonyls. So we're going to go into the different types of carbonyls we have, how to make aldehydes and ketones, and what reactions we can do with those. So what is a carbonyl? A carbonyl is a functional group that has the C double bond O depicted right here. So if you have a C double bond O with two hydrogens, this is the simplest type we can have, and this is known as a formaldehyde. If you increase the substitution and add on an R group, it could be anything as long as it has, like the carbons and stuff. So one R group and one hydrogen is an aldehyde. If you move forward and add on another R group, they can be the same or they can be different. This is known as a ketone. And then the most oxidized carbonyl has the C double bond O, one R group, and an OH group. So this is known as a carboxylic acid. Down here, I just have showing that with resonance, if you move this up, the carbonyl carbon is what holds the positive charge. So this is the most electrophilic position on the carbonyl. So how do we make aldehydes and ketones? Remember, aldehydes and ketones are two types of carbonyls. So with ozonolysis, you guys have learned this before. You don't need to know the mechanism. All you need to know basically is that with these reagents, you're going to cut the double bond, and on each side of that double bond, you're going to add in oxidants. So the double bond is between carbons 2 and 3, so we're going to cut that in half and add in oxygens. So right here, notice that the bond between 2 and 3 was cut, and you just add in oxygens. And because the substitution of this alkene is just one on this side and one on this side, so that means there's a hydrogen here and there's a hydrogen here, so it forms an aldehyde. If you increase the substitution and add on additional methyls to carbons 2 and 3, and you do the same reaction, you're going to form ketones. So we could just cut the double bond between 2 and 3 and add in oxygens. See, the bond between 2 and 3 is cut, we added in some oxygens, and the new methyls 6 and 5 are there. So because this carbonyl has two R groups, it makes ketones. Another way we can make aldehydes is with alcohol oxidation. These are fairly recent reactions we learned in class. So with primary alcohols, you can use the pyridium chlorochromate oxidation, which is the PCC one, or you can use SWERN. Both of these will result in aldehydes. And moving forward, if you use these same reactions, PCC and SWERN, on secondary alcohols, these will result in the ketone. In addition to PCC and SWERN, we can also use chromic acid oxidation with the Jones reagent, and this will also form a ketone. We can't use chromic acid oxidation on primary alcohols to form a aldehyde, because if you use those reagents on a primary alcohol, it actually results in a carboxylic acid, not an aldehyde. Another way we can form ketones is through Friedel-Crafts acylation. This is when we start off with an aromatic ring, use the carbonyl, and and aluminum trichloride, and it just sticks it onto the aromatic ring. Now, what reactions can we do with aldehydes and ketones? So we can reduce them. We can go from the carbonyl group to an alcohol. So the two reducing agents that we know are sodium borohydride and lithium aluminum hydride. They do the same thing. They reduce the carbonyl down to the alcohol, but the only difference is that lithium aluminum hydride is much stronger than the sodium borohydride. For example, these will do the same exact thing for ketones and aldehydes, but if you had a carboxylic acid, lithium aluminum hydride is the only one that can make it go down to the alcohol. Sodium borohydride is weak, so it wouldn't be able to reduce a carboxylic acid all the way down to an alcohol. But with regards to aldehydes and ketones, just know that these two do the same thing. The last reaction we're going to talk about is a Grignard reaction. You can see that the carbonyl still does get reduced down to an alcohol, but the difference between these reducing agents and then the Grignard reaction is that the Grignard reaction is a bond-forming reaction. So in addition to forming an alcohol, the bond is going to be formed between carbon 6 and 3, which is depicted right here. This is the bond that is made. So yeah, I hope this guys helped with a lot of review. Just this is a lot of stuff we've learned within the past couple weeks, and now we're just applying it. So thanks for watching, guys. See you guys next time.